Reuters reports that the operator of the wrecked Fukushima nuclear plant took the first steps today in the long and hazardous process of decommissioning the facility. They extracted 4 fuel rods from the container for later removal. Tokyo Electric Power Company, known as TEPCO, said it transferred the rods to a steel cask within the same cooling pool. It begins the delicate and unprecedented task of removing 400 tons of highly irradiated spent fuel from the reactor. With me is Arnie Gundersen. He's chief engineer at Fairewinds Energy Education. They try to demystify nuclear power. Thanks for joining me, Arnie Gundersen.
Hi, thanks for having me.
First of all, can you kind of set things up for us here? Remind us what is going on at Fukushima. They had 4 reactors, and this was the one that wasn't turned on, so you would think that it was the one that would be easiest to deal with.
It is the one that's easiest to deal with, which makes this truly frightening because it's such a difficult project. The nuclear fuel is stored in a fuel pool. It's not much different than your swimming pool, except it's 50 feet deep. And at the bottom of the pool are racks where the nuclear fuel is stored. Now, back in 2011, when the plant had an earthquake, the plant shook so violently that almost 4 feet of water sloshed out of the fuel pool. So think about your swimming pool moving sideways so violently that 4 feet of water slosh out of it. So that was the beginning of the problem. The fuel racks at the bottom of the pool were damaged by the earthquake. But then, worse than that, shortly after, the building had an explosion. So the roof fell in on the fuel racks. Now, I used to build fuel racks, and the tolerances are very, very high precision. And if they're damaged, if the fuel is in them and the rack is distorted, it becomes extraordinarily difficult to pull the fuel out. Almost like a pack of cigarettes, you can pull the cigarette out pretty easily unless you distort the pack, in which case it becomes really hard. So the problem facing the people at Tokyo Electric on Fukushima Daiichi Unit 4 is that, 1, the rack was distorted by the earthquake, and 2, the roof fell in on what was left and further damaged the rack.
And right now they're trying to go in there and get some of the worst fuel rods that were possibly damaged?
Well, right now they pulled the easiest fuel rods, the least problematic of the fuel rods. There were about 20 or 30 brand new fuel bundles in there. And new fuel is new iron. It's not brittle. It's very ductile. So they're trying this attempt on the new fuel, which means that it's the least likely to have problems, because it wouldn't have been in a nuclear reactor for up to 4 years. So it's not anywhere near as brittle. So they're practicing this week and perhaps for the next month on these new fuel bundles before moving to the really difficult stuff.
How is this different from moving fuel bundles, which TEPCO does all the time? Because it seems like they've taken a lot of extra precautions here. They've built an esophagus. They've built this crane mechanism inside the esophagus that's doing all this work. But is that a lot different than regular?
Well, and actually they're doing it out at Zion right now. By the way, near you, the Zion nuclear plant is moving fuel.
And this is something that is common. Everybody puts their fuel rods out in these pools. This is where you store your spent nuclear fuel all over the place.
Correct. So the storage of nuclear fuel and the removal of nuclear fuel from a rack is something that's done. Like you can't say day to day, but certainly on a yearly basis, fuel is moved in a nuclear fuel rack. The problem is maybe threefold. First off, these racks are no longer as designed. They've been beat up by sliding side to side in the earthquake. The second off is that they have rubble in the rack. And the third piece had to do with the building. The building was structurally compromised. there was at least 2, if not 3, explosions in the building, so that there was no envelope over top of the fuel pool, and it was exposed directly to the air. So what Tokyo Electric had to do was put in a new crane on the existing old foundation in order to do these fuel lifts, and then they covered it all in essentially a shrink-wrap building that was constructed in the last 9 months or so. The purpose of that building is so that if they break a fuel bundle, the radioactive gases are not released at the ground level, and they run through filters before being released up the stack. So the building is designed as a containment envelope to release radiation up the stack in the event that they break one of those fuel bundles.
Is that the worst-case scenario, breaking a fuel bundle?
Well, there's 2 worst-case scenarios. First off, though, they have to do this. My problem is really with Tokyo Electric doing it as opposed to it has to be done. The building is structurally compromised, and Unit 4 worse than the others because it has more nuclear fuel in it. So it's not something that can be delayed by 10 years or something like that, because the threat of an earthquake is significant, and in a compromised building, it could really cause a serious radiation release if the building were to collapse. So it's important to move the fuel. There's no doubt about it. But the 2 problems are snapping the fuel as they lift it out. And that's happened here in the States. Periodically when you go to pull a bundle out, it gets distorted and it breaks. And inside are radioactive gases, particularly krypton-85, that are released into the atmosphere. The other problem, though, and this is unique to the Fukushima site, modern fuel racks have boron in the surrounding the nuclear fuel. And the boron at Fukushima Daiichi likely leached out over the last 2 years for 2 reasons. The water was very hot. It was boiling. And this boron was never designed for boiling water. And on top of that, because they ran out of normal cooling water, they had to add salt water. So the boron wasn't qualified for salt water, and especially hot salt water. The boron prevents a chain reaction from occurring in the fuel pool. So what Tokyo Electric has had to do is add the boron to the water, because there can be no confidence that the boron plates that separate the fuel are any good anymore. If the fuel gets too close to each other, it can cause a chain reaction in the fuel pool. Now, the fuel pool isn't designed to handle that kind of heat. So what they would have to do is very quickly, if they start to see local boiling, because you would begin essentially to run your nuclear reactor in the fuel pool, they would have to quickly push the rod back into place and hope that the chain reaction stopped. And that, of course, assumes that the rod can be pushed back in. The problem here is that with the distortion of the racks and the rubble, the friction on these bundles can be significant. And as they start to pull them out, they can get stuck, so they won't come in or out, or they can perhaps be pulled out, but perhaps not be able to push back in the event of a problem.
Arnie Gundersen's chief engineer at Fairewinds Energy Education. We're talking about the Fukushima nuclear plant and moving the fuel rods in and out. The process began today at Reactor 4. So the reactor, if it goes into one of these, where it kind of gets to the free, what's the term you use? Where
inadvertent criticality.
That's it. What happens then?
Well, the problem in my mind is that Tokyo Electric hasn't thought that through. In my opinion, they should have 2 things. They should have excess boron in liquid form that they could rapidly add into the fuel pool in the event a chain reaction did occur. And the other thing is they should have a lot of excess water in the event a chain reaction occurs to make up for what could potentially boil off. And this is where an experienced engineering firm would have more checks and balances than what Tokyo Electric presently has. They've been underfunded for the last 2 years. The Japanese government is trying to do this on a shoestring, and they're demanding all the money come from Tokyo Electric. So what they've done is they've stripped funds from their other reactors in order to keep funding Tokyo Electric's Daiichi site. But the net effect of that is that they haven't had the right manpower. They haven't had well-paid enough people to attract high-quality people, et cetera. So we're in a situation now where they're trying to do it themselves rather than rely on the international expertise that's out there.
Now, I read a quote from Lake Barrett. He's a former U.S. nuclear regulatory person who was involved in 3 Mile Island, and he said that he'd been invited by TEPCO to review their contingency plans, and he found them thorough, and he said, I'm not trivializing what's an important operation, but the technological safety risk of moving the fuel is very, very low, and I believe they're ready to go.
I know Lake Barrett. I worked with him back in the 70s, before 3 Mile Island, and he's being paid by Tokyo Electric to make that assessment. I think you have to keep that in mind. Also, on the 3 Mile Island accident, he was basically the government spokesman, and that quote could have been 20 or 30 years ago as well. But I think the risks are significant, especially with Tokyo Electric doing the work. Like I said at the beginning, it has to be done. This isn't something that should wait a year or 2 or 3. But the unfortunate thing is that I don't think the operator has put in enough contingency management. In the event things go bad, there's not enough contingency there. I was in Tokyo last year, and I got to question Tokyo Electric about the unit 4 fuel pool, and I found that they were woefully unknowledgeable about the problems that spent nuclear fuel can have. It was in the diet, which is their parliament, and in questioning them eyeball to eyeball, I found their staff to just not appreciate the magnitude of the problem that they were facing.
Now, this is a problem that's going to go on for a full year. They anticipate it would take them a full year to get the rods out, and it could take more.
They have another, at Kashiwazaki Karyuo, which is their other big nuclear plant. They have 8 nuclear reactors on the Sea of Japan. It experienced an earthquake about 5 years ago, and they never got some of the fuel out of the fuel pool because it was so distorted that they couldn't pull them out. So I think they're going to find the same thing here. They'll pull some bundles that will come easily, and then, they've got to have a plan B in place that when the bundles don't come out, what's the next step? And I think they'll have to create some remote cutting techniques, so the rack would have to be literally cut apart around the nuclear fuel in order to release it so it can be moved. And again, that's one of those areas of expertise that I don't think Tokyo Electric brings to the table.
Arnie Gundersen is Chief Engineer at Fairewinds Energy Education. Thanks a lot for joining us and talking about what's going on at Fukushima.